presenter Van Loon, the CEO of Intelligent World, an advisory board member at Simplilearn. A little bit, I'll see it here. You don't want it just to show up to me. And we'll start off with a quick poll. We'll do a poll at the beginning and the poll at the end of the presentation. And this quick poll first asks a little about you. I'd like to know what job role you currently fill. And we also like to know how you're feeling today. We've been asking this since the start of the pandemic. Check in on everybody's emotional state. And just 15 more seconds. And we'll close the poll. Here are the results. So the two biggest groups with us today are students and people in other job categories, but we do have a number of managers and analysts and a few data scientists here. So this will be a very informative session. Let me introduce Ronald to you. And Ronald Van Loon is the CEO of Intelligent World. He's a world-renowned expert in data science and digital transformation, named as the #1 influencer in data analytics by Analytica. And he writes for several major blog sites for big data and data science. And he's an advisory member of the educational board at Simplilearn. So we're very pleased to have him here today. Thank you for joining us, Ronald.
Yeah, I'm pleased to be here as well. It's very great.
Okay, so we can move on to the first question. And the theme today is we're experiencing an explosion of data as more and more devices get attached to the internet, as the Internet of Things takes over, but also as more and more of our daily lives is digitally transformed and moved into the digital domain. How does this this transformation and this deluge of data challenge data scientists and data analytics professionals in their careers?
Thank you, Stuart. On one hand, thank you for the kind introduction. And of course, thank you and I appreciate everybody being here today and for joining us. Before I answer the question, maybe it's good to give a little bit of an introduction and introducing the theme and as well why it is important. And Stuart was already mentioning it. Our daily life is changing and it's creating much more data. And the reason why we're here today, I think, is that we want to talk about the data scientists and the data analytics professionals and their evolving roles in the future of data analysis. And related to that, the massive growth of data. Because this, they play a very important role, you as a data analyst, as a data scientist, in the part of the advancement and development of organizations. It's so important to update yourself. And what we see is that data scientists and data analytics professionals, they often have a lot on their plate. And this is only becoming more, I think. So it's not only relatively new type of line of work, but what you have compared to traditional jobs, which we had over the past 5 years. But if we look to data science and data analytics more from a general perspective, the data science and data analytics professionals, the roles, they are evolving quickly over time alongside with the technology and the capabilities that we have, compute power, storage power, etc. So at the same time, what we see as well is the responsibilities of the data scientist and the data analyst within the organizations. They might change, and it's depending on the unique business and their needs, as well as what's expected of them within that individual industry. Every industry has its own specifics again. And as a result, what we see is that data analytics are changing. So there's a lot of data volume and the data landscape to traverse, and data scientists and analytics professionals, they need to be prepared with the right tools, but also the right technologies, the skills and the proficiencies that help you to keep up with the pace of the changing data environment. And that's moving fast. So there's a lot of factors influencing the explosion of data volumes. And the necessity for advanced analytics is there to change. So we already know that COVID has accelerated transformation for the industries, and it's impacting data as online customers' behavior and digital channels change and increase as well. New type of applications come to the market every day, and there's also new type of data partnership being introduced between all the different businesses. There's leadership roles that have a lot of new responsibilities, and also with working remotely. We see the interdisciplinary teams also have new roles to consider to revolve around data and all around analytics. So data scientists and data analytics professionals have an important role to play in preparing everything around the business for the future, and navigating this explosion of data volumes and the impact that it has across all the different organizations. So if you're a data scientist or an analytics professional, or you want to become one, I saw a lot of students in the session now. You're, I think, in a tough spot. You know, this career path has a lot of opportunities, but you also have to learn how to change, how to adapt, how to evolve alongside the massive impact that data is having on the world and the business itself. So it's not easy, but with the right knowledge and the right education, you not only be successful as a data scientist and a data analytics professional, but you'll be able to keep up the pace with the impact that massive growing data volumes have had across all the industries. So let's now dive into the conversation and basically dive into the question that Stuart asked about this, the impact of the data explosion for your role as a data scientist and as a data analytics professional. So if we look in just around 5 years, the global data creation will hit over 180 zettabytes. And this was much higher than initially anticipated before the pandemic. And due to the pandemic, this increases. And in 2020 alone, it's already 64 zettabytes of data that was created. So what we see is that the volume of data is causing some kind of trickle-down effect across many different areas of data science and data analytics. This also includes the diversity of data, as it's coming from many different sources. Like you can think about IoT devices. The one that everybody knows is mobile phones, but also you can think about sensors on manufacturing equipment or online customer data, for example. So these large volumes of data and data diversity, that's a challenge for data science and for data analytics professionals. They need to be able to interpret this data and derive actionable insights and positive outcomes from the data. And to do this, you have to bring together this disparate data and all this silo data. And what we see is that a lot of organizations they're generating and collecting and computing data on-prem, but also in the cloud, on the edge, or in a hybrid or in a multi-cloud environment. We also see that businesses need to be able to use data in real time for advanced analytics. And we see that the volume and the diversity of data is building up at the same time, that organizations are adapting to and exploring all this new type of storage and all kinds of new compute systems. So data science and data analytics professionals, they have to keep the pace and be adaptable in the face of data volumes, but also in the face of diversity of the data. And the data environments today, they're often highly distributed. So the data scientist and the data analytics professional needs access to more and more to real-time data. And this is why there's an impact across many of the areas of data science and data analytics, because this affects how they approach data management. It affects how AI systems and AI platforms are working, and how they build data ecosystems and how you build your architecture. Just a common example is that data scientists and analytics professionals have to work with legacy and on-prem data. But organizations they're making that move more and more to the cloud. So they have to bring together all these type of different data and technology environments in order to basically best utilize the data from the organizations. And the problem is that this can create inconsistencies in the data when data needs to be synchronized, because there's a lot of tools available to help the data scientists to migrate the data from on-premise to on-cloud, for example. But that's one of the challenges. And being able to keep all that data updated and to keep all the data consistent so that the data isn't complete, isn't redundant or inconsistent, that's an entirely new story with the new volume and the new diversity of the data. So for example, if journey data isn't updated properly, customers might go online to the online store and get promotions from the products they just bought. And this is a poor customer experience, which you're trying to avoid. So data scientists and data analysts, they are charged with developing a data architecture so that they can have access to real-time data, but also resolve the inconsistencies and aggregate the data from all different kinds of sources. And this is quite a challenge for both the data scientist and the data analyst, and especially with businesses who have decades of old legacy systems in place. And they have to modernize the data architecture. They have to bring together these traditional infrastructures with the modern applications that connect your systems. So you have to solve the disparate data and the data volume challenges. And you also have to work on the data management challenges. And at the same time, you have to improve the data latency, which is another common challenge if when you're trying to use moving to real-time data for more advanced analytics. So on top of these common scenarios and challenges that data scientists and data analysts have, um, increasing data volumes also impacts the less obvious aspects of data science and your data analytics life. So for example, you also have to be prepared for rapidly shifting regulatory requirements, such as with governance best practices and protocols that change approaches to ethics, to security, to privacy, especially around your personal identifiable information. So businesses, what we see is that they are implementing these new policies that impact the way the data scientists and the data analysts approach data collection, but also your data lineage and your authentication. So the bottom line is that data volumes are growing, and this creates more complexity and more challenges for the data scientist and the data analytics professional. And data science and data analysts, they need to embrace this new type of flexibility and adaptability in their everyday job. So this helps them to be prepared for this impact of this large volume of data. And this also helps you how help you to work in the different areas of work that you have, from the way you approach data management to the systems and technologies that you use, to your approaches to AI, and even to new policies and new regulations that can change the volume and the complexity of your data. So how can you, as a data scientist or data analytics professional, prepare yourself for this constantly growing and evolving data landscape that has an impact across so many different areas? And that's what we are here today to talk about, and that's what we need to think about and see how we can solve that. So Stuart, I hope this gives a good overview, how this explosion of data really impacts the data scientist and the data analytics professional.
Yeah, that was a excellent overview. And the next question that it leads into is, businesses and business environments are changing because of digital transformation and the data explosion. And um, so the needs of business are changing. And that means what businesses demand from data scientists and data analysts um, is changing. So can you give us some observations on that, and maybe also on um, the different roles of the data analyst versus the business analyst?
Yeah, definitely. So business is changing fast, and especially now driven by this pandemic, they need to change faster and faster, and we see, let's say, more compute power coming available. So it is easier to change faster as well. So this will not slow down anymore. And we briefly mentioned before that accelerated digital transformation and modernizations are fueled by the data, and that's what's going to be the backbone for I think the answer of this question. So organizations need to innovate, and they need to provide new products to stay up to date. They need to provide new services and solutions to their customers, and this requires also new potential partnerships, new technologies, but also new data models, for example. So I did some research, according, for example, to McKinsey. In banking, 70% of the surveyed financial institutions have had a modern data architecture roadmap for, let's say, 18 to 24 months, but almost half still have disparate data models, which is a big challenge. And I think if you look at that, on top of that, they have to adopt these new technologies that are going to help them to get to this future type of architecture. And when you think about banking institutions, there's also, I think, an additional added layer of complexity, because many of them have been operating for decades, and many have a lot of legacy technologies and a lot of legacy processes in place. And when we talk about the business processes, this is often one of the most difficult areas for businesses to navigate, how to change this. It's not just the technological implementation that's difficult, it's changing the shape of business processes in order to get it all done. So leadership teams, they need to have and they need to learn how to navigate this type of new and new type of complex area as well, in order to see these data roadmaps and these type of data frameworks take shape successfully. And that's quite a hard process, especially as I mentioned, in banking. So businesses and technology rollouts, what we see is that they have more to coincide in order to recreate their own business landscape, both internally as externally, and develop new type of data architectures and replace the existing data architectures. So having this new data architecture requires some kind of foundational shift for your business. You can imagine if you start replacing your foundation, your fundament of your business, that's a substantial impact. So they start where your data is being accumulated and where your data is being stored. And yeah, if you look now how data is stored, you can think about the cloud or edge or on-prem. And then what we see is that organizations, they need to implement advanced analytics. So they need to have this real-time data to make the most of that transformation reality. And data analytics needs to be unified so that eventually you can apply AI and machine learning solutions, and they can be designed and implemented. And this is just, let's say, a simple explanation, an example of how data architectures and business landscapes are changing as a result just of this massive data volumes and this massive data diversity. And then the data scientist and the data analytics professional, they are there to help the business leaders to reach their goals while they implement this long-lasting technological solution. And that's, I think, a heavy task for a data scientist. The C-level executive often don't know how to do it, and it becomes your responsibility, of course, with a bigger team, but that's a big responsibility. And this impacts the future of data science, and this impacts the future of analytics, because your contributions, they're going to have a lasting impact on the business. And they will be required to not only grow and maintain new solutions, but also adapt over time. So now let's take some time to talk about some popular use cases to make it more concrete that are causing this this shift in business landscape and impacting data science and impacting the data analyst type of career. The first one, there's, for example, predictive marketing. Predictive marketing helps to forecast customer behavior so that businesses can make intelligent strategic marketing decisions. And data is taken from the customer, from the purchasing habits, in order to tailor future experiences and impact all the different type of marketing channels, cross-channel. So this can be used to enhance your research. It's used for your advertising, but also it's used for identifying risk and issues and many more applications. What we see as well is that organizations are adapting their entire organization structure to prepare for the future marketing demands. So predictive marketing will drive all different kinds of business opportunities. And the data scientist and data analyst professional, they're going to heavily influence this predictive marketing solutions. So you have a direct impact on how your company is communicating to the clients. You have a direct impact on the results, on the conversion, which is a heavy task. Another popular use case, for example, is what they call AML, anti-money laundering. So many financial institutions are impacted by the threat trends like crypto currency related risk, trade finance, or you have synthetic identities as cyber criminals take advantage of these new technologies, but also available compute power and weaknesses in anti-money laundering control to commit these financial crimes. And some other research I did, if we look to the United Nations, they forecasted that the approximate amount of money laundered globally in just 1 year is between 2 to 5% of the global GDP, 2 to 5%. And that means between 800 billion and 2 trillion, which is a substantial amount. So only this is already such an interesting domain where they need many great data scientists to help them out and solving this challenge. So when you think about the rise in this digital first mobile banking experiences, and especially during the COVID pandemic, what we see is that people are increasingly managing money and other accounts online. They don't go to the banks anymore. And for some countries, that's obvious. For some other countries, it's, let's say, a big change. And this also puts a new strain on the financial institutions to quickly upgrade their systems and to upgrade their approaches with automation, with analytics-driven solutions to better protect their customer and their assets from all these diverse risks, like account takeovers or peer-to-peer payment fraud and all different kind of other tricks that criminals are thinking about and applying on your bank account. So many of these solutions, they are AI powered and they rely on copious quantities of data, as well as advanced analytics techniques such as deep learning or federated learning in order to help the institutions to continuously anticipate on this new risk. And the amount of online customer transaction, that's also going to grow. So you can see how important this type of work will be for the data scientist and the analytics professional. So not only within the financial institution, but from a technology vendor side as well for such a solution development. Another important use case is master data management. If you listen to me on other sessions, you hear me talking a lot about master data management, which helps to reinforce and to categorize enterprise data. So using various technologies and applications, you can better prepare your data analytics. So businesses need enterprise data to be visible, organized, and to be unified. If enterprise data is disparate and disconnected, you can imagine analytics is inaccurate and business strategies are at risk of failure. You can take, if you take decision on wrong data, it's not going to work. And this includes data like customer data, but you also can think about your product data or your partner data or supplier data and many other type of data. This impacts your supply chain. This impacts the marketing, impacts your IT, your human resources. Basically, every aspect of your organization is impacted by this. And then as well, data needs governance. It needs to be trusted. It needs to be standardized. So organizations need this holistic view that helps them to rationalize their decisions. So our case study examples in predictive marketing or on anti-money laundering or master data management, they're all cases that impacts data science and data analytics professionals. So we talked about how important it is to think about how you are going to differentiate yourself and how you are going to specialize in specific areas and in specific domains of interest. So you can think about specializing in predictive marketing, or in anti-money laundering, or in master data management. And that's worth a second look to dive into one kind of specialism. So understand that these areas, they're only showing a wide spread of future growth. And the more you can learn about these areas, the more you can understand how you can make an impact on the future of these organizations, and with that also on your own career. Now, we briefly touched based the legacy technologies, like our banking example, but the truth is, a lot of organizations, they are letting go of these legacy technologies and systems and processes. They have to, basically, to survive. So legacy systems are becoming cumbersome. They require a lot of resources and are adding unnecessary complexities to the business development and to the growth in a time when modernization is really key to your competitive advantage, to your sustainability, and to your business continuity even. So organizations need to be prepared to change and to set up this new business landscape that facilitate the data usage. And then you have the technology leaders, much like data scientists and data analytics professionals, who are focusing on training and education in order to encourage the business leaders to increase and to improve the technologies that advance these type of data initiatives in order to improve the workflows, in order to enhance your customer experience, which is really key, and just overall make everything easier and more automated to operate. So the data scientists and data analytics analysts, they are part of this culture that is all revolved around the data. And if you are a data engineer, for example, you have an important role to play in the culture and in the architectural development. And you have to constantly be learning and training and updating yourself and understanding how to automate your data pipelines, how to automate your modeling. So what we see is that the point is that continuous learning is going to be a part of your journey as a data scientist and as an analytics professional. You have to constantly educate yourself. You have to updating your skills. You have to grow your knowledge, because as you can see, data and business landscapes, they are growing, they are evolving very, very quickly, and you have to grow and evolve alongside with them. And if we had the same discussion next year, we will see that the development would have changed. So think about how quickly things have been changed after the pandemic, and be prepared to embrace this change in your career. So Stuart, yeah, the let's say the large data volumes really have an impact on the business landscape, and they have directly an impact on the data scientist and the data analytics as well. So it's important, and that's all I have to say.
Okay. Well, you said it very well. And you've illustrated, you know, with concrete examples why that's the case. Um, so this is in line with some of the questions that have been coming in. What kinds of skills and proficiencies um, do data scientists need to learn first to have a foundation in the field, but then what do they need to do the ongoing keeping up that you described? Um, Excuse me while my phone does something strange. Apologize for this. Okay, and so what new skills, what emerging skills and tools do people in this field need to be aware of?
Yeah, good question, and hopefully I'm going to help you step by step, going to answer all the questions, all the old skills transformation and the new skills. So the last point that I made was about this continuous learning and embracing the change in your career, so you can evolve and you can grow alongside that the business and technological advancements are there. And I think this is a good lead into the topic, because we can talk more about what you need to learn and what helps you to prepare your own career. Always look from your own career perspective how it can help. But let's first talk about a few technologies that you can learn and that can you help you along the way. So most simple to start is you can start with data visualizations. Um, they are a great place to start. Visualizations can be diagrams or tables or charts or graph or animations or maps, all different kinds of visualizations that help you make sense of data and information. If you have no experience, this is a perfect way to start. And data visualizations are great for showing different ideas, for strategies, for trends, for patterns. So as a data scientist, a data analyst professional, this helps you in your communication. And communication is really important so that you can visually articulate what data can do and what the story is that data tells. And you have to communicate to all different kinds of teams, to the leadership, to different stakeholders in a way that they understand it. They are not analysts, they are not data scientists. So you need to communicate it in a simple way. And data visualization tools, you can think about Tableau or Vega, or they help to make data visualization very easy and more simple, and help you in better communicate what the data, what type of story the data tells. And it's not just about, let's say, the data scientists or data analysts who are using them. Management and C-level executives are using them as well, but it helps to explain the concept and the strategies. So how is data visualization and these corresponding tools going to change moving into the future? They are likely to become more responsive. They are going to be simplified, more interactive, more predictive, more natural language driven. So on one hand, learn everything about what you can about is intelligent dashboards and data visualization now. But it will be more and more automated, that every person who has no clue from analytics can use it. Keep that in mind. But it's good to start with that if you have no experience at all. So next, let's talk about a very important part in the AI domain is deep learning. Again, some research, McKinsey, they said that just 16% of the respondents say that their companies have taken deep learning beyond the piloting stage. Deep learning is still early stage. If we look to the high tech and the telecom companies, they say already that 30% of the respondents in those sectors say that companies have embedded deep learning capabilities already into their processes. So depending on the sector, you see deep learning evolving or evolving faster. And remember when we talked about this specialization in certain industries and certain technologies, deep learning is one of those areas you want to learn as much as you can. And if you're interested in telecom, you can see how you can gain a competitive edge just by looking at this statistic alone. Telecom is a great industry to be in. But of course, you can also be in banking or in any other industry. Every industry uses data, and every industry will, if they don't do yet, use deep learning to further automate all different kinds of applications. Another example, for example, deep learning is used for image analysis or healthcare ailment and disease predictions, but also what everybody's talking about, autonomous vehicle technology, self-driving cars. And it's also used, for example, what we talked about, fraud prevention, anti-money laundering, which which basically we discussed before. So if you study deep learning, you will learn more about neural networks. You will learn about using algorithms in image and video analysis, using natural language processing, and often learn to work with, for example, Python or TensorFlow. Deep learning is pretty cutting edge AI technology. So it analyzes from different sources in real time without any need of human interference. So it's used a lot in automation, and we see a lot in our everyday lives. For example, with speech recognition, when you use Siri or Alexa, maybe you're not even aware of it anymore, but in your daily life, many applications are driven on deep learning. And if you really want to stay ahead of the game, then you should really improve your understanding and your skills related to deep learning. So let's take some time to talk about machine learning, because what we are really talking about is getting AI to perform how we want it to perform. And I don't have to tell you that AI is the future. Um, yeah, I think that's so obvious, and that's probably why a lot of you are here today as well. You need to improve your knowledge in machine learning. Another statistics from Deloitte, in 2020, Deloitte survey found that 67% of the companies are using machine learning. So that was already last year. And in this year, it's 97% are using or planning to use it. 97%. So there's hardly any company left that's not using it. So right now you can see most of the companies are trying to use machine learning in their business, and they do it on an everyday basis. So when we talked about businesses overcoming legacy systems and challenges, machine learning is the key to helping them to solve those problems as well. And since this conversation is all about data, machine learning is an integral part to this discussion, because machine learning uses data to train machine learning models, of course. So if today's discussion is about what to do with the explosion of the data that's only growing exponentially, you can see why we are talking about machine learning now. Whether it's supervised or unsupervised or reinforcement machine learning, the goal is to try to build evolving and self-sustaining systems. So there's just simply too much data and so much value that we can get from that data, um, as we as people, we can't be without it, because we are impacted by this technology every day, and businesses can't operate without machine learning anymore. For example, the most obvious thing which you use every day, how would Google use their search engine without machine learning? It's impossible. So as a data scientist, as a data analyst, it's going to be your job to use machine learning to usher in this era of explainability, or rather help these machine learning models to make the most accurate and best decisions. And there are so many different industries, so many different type of applications. You can specialize in so many different ways. And that's something that you should think about, but start somewhere and start finding your own path, and from there you can start basically specializing based on what you like, based on what you're good at, and drive your way through. Which brings me basically to the next point, which we haven't discussed too much yet, is big data. So you can't go anywhere these days without hearing the term big data, becoming even more just data. And it's the heart of our discussion today, really. But let's talk a little bit more about other technologies that might need to be related to big data. You can think about Hadoop or Apache Spark. These are open source frameworks for managing big data sets, where Hadoop is good for working quickly on a limited budget, and Apache Spark is great for analyzing stream data analysis in real time, or for machine learning applications. And I won't go in great detail right now about the technologies, but the point is that businesses across the industries need big data management type of solutions, and we discussed that there are they are building and they're developing their data architectures and their ecosystem within their organizations, and this is the foundation. So you can see that having knowledge in this area is going to be fundamentally in your technologically learning development path as well. All right, we talked about technologies that you are going to need to learn, but let's talk about some skills that you're going to need too. So uh, programming. Programming is going to be one of those integral skills that you want to be good at. Of course, at the beginning of this conversation, I did mention the disruption of to the world of programming, with low code, with no code frameworks becoming increasingly common. And you have to be prepared for this evolution and the reality moving into the future. But as of right now, programming with the use of Python or SQL, for example, is going to be part of your life as a data scientist or as a data analyst. You also need mathematics, you need statistical education and the knowledge as well as a foundation in which is yeah, let's say a foundation in your computer science is as a prerequisite as well. So most of you here today probably know that programming and mathematics and computer science are a very common area of your study for the application of data science and data analytics. And I won't get into great detail right now, but the point is that these skills are going to help you preparing you for your future, that's built on this massive data volumes. And that the most online certification educational courses and institutions are going to teach you this. Of course, Simplilearn as well can help you with this. So there are, if these are new areas of work for you, I think this is a great place to start as creating that foundation for your own career path. But for those who aren't new here, when it comes to your knowledge of this career path and are thinking that it's pretty obvious to mention programming, mathematics, and computer science, what you might not know is that there are more advanced areas of your study. For example, is strategy development. And this is all about advanced analytics, because what we see is that businesses need to transform in a way that they operate, and you need to know how this happens. Because when you get hired, people are going to directly involve you in the processes and even look to you for the answers. And you need to be able to strategize with your company, with your co-workers, and with your other business leaders. And you have to be able to show in real time how strategies are panning out so you can help your business to make the best moves for success in this changing environment. So you have to help to reduce the bias in decisions to improve planning. For example, you have to anticipate what's going to take place under a variety of dynamic market movements and fluctuations, which can be very hard right now because often there is not even data from these changes, as we have seen in supply chain changes in the last year, where there was no data how to manage it. And this is really what's going to make you a real star in the field. So this is something that's harder to teach. It's harder to learn. And experience in business is going to help you to learn more about this. Talk to executives, talk to peers, try to understand the business and try to find out what your end user wants and how data can help. And then think about as well in an easy to use way. So if you can learn to have a strategic mindset in your approach to advanced analytics, you can align yourself with the needs and the goals of business across industries and truly understand the impact of your work as it relates to these greater objectives that an organizations have and align with the strategy that they have. So Stuart, I hope this gives again a good overview of the skills that the data scientist and data analyst needs to keep up with this fast paced and fast changing environments within organizations.
Yes, it does. Our last topic is what pivots do data scientists, data engineer, data analysts need to plan for? Um, what are the steps they can take when they're making these transitions?
Yeah, let's try to make it more concrete. We mentioned throughout this conversation that ongoing education is going to be a regular commitment that you have to give. You need continuous education because this field will always be growing and it will be always be changing and always be evolving, and it will go faster and faster and faster. So you want to stay up to date with the latest tools, the latest technologies, the latest trends, the latest developments, not to mention even the need for specialized talent across different industries. So you have to stay current on new innovations so that you don't get left behind. I think that's the key. So for this rapid growing analytics environments, you need to to position your knowledge and your education around data. You have to know how to reveal trends, how to reveal your patterns in the data. So you need to understand where to gain insights that are going to help you and your business to innovate with new products, with new services, and with new solutions, and try to think from your client perspective, and then how you can help the client. Ask your peers in product marketing and product development, um, in even, let's say, customer review sessions. Try to understand what's really needed and how you can help the client. Then you become very valuable for the organization. Forecasting outcomes is going to be a regular part of your job. And you need to learn as much as you can about algorithms and model development. And this includes pursuing a bachelor or a master or a PhD in modeling, or in forecasting or in statistics. And also staying informed on emerging analytical trends that can help you better adapt your career and can help you with adapting your skill set. So for example, cybersecurity is a huge trend and a huge issue right now, because with this widespread shift to digital and the increasing what we call productization of personal identifiable information via the dark web, security becomes really key. So these kind of trends are reflected in data scientist and data analyst career opportunities. And another statistics, according to ZipRecruiter, the average annual salary in the US for a cybersecurity data scientist is almost $125,000 US dollars. So you can imagine what you can do if you specialize in this field, and how substantial the demand is, and on the other hand, how substantial your impact will be on organizations, on the world, if you develop applications in the cybersecurity domain. So a data scientist who wants to pivot their career to get into this field, for example, they can explore some interesting job possibilities, such as a cybersecurity engineer, and use your existing mathematical, analytical, and programming and problem-solving skills as a foundation for this. As you can also build on this, you can continue your educational journey. Firstly, research the job role that you're interested in. That's always good to start. So in this case, if this is a cybersecurity engineer, they build and they construct information security systems, devices, and applications. So you need to get a BA in information security, in cybersecurity, and probably another relevant area. And this will probably entail courses in cryptology, probably in network infrastructures and computer science, and probably some more. And if you want to pursue a master degree, then you need to fine tune your area of interest even further. And this might be something like authentication technologies, or even cyber terrorism, which is a hot topic right now as well, and it will stay a hot topic for the coming years. Also, I suggest you continuously build a portfolio and test your knowledge and your skills across different cases, across different industries and environments. This portfolio helps you, on one hand, to look back and see, hey, what did I do, what I'm good at, but especially as well to present yourself if you want to move into a certain direction where you can, yeah, let's say, customize your portfolio and show what you've done, what you've learned in different industries, different cases, different technologies, different studies, to build yourself specifically for a specific area where you want to specialize in. So one of the great things about this line of work is that you can build your portfolio based upon real world business scenarios. And that helps you to gain experience and also land good job opportunities as well. If you have some experience, it's easy to move your career and your journey forward. Now, we just went over the basics here about pursuing your education and building a portfolio, but I'd like also to get more in depth and tell you about things that you might not know or not able to find elsewhere. And that brings me to the next point about building models versus business decision making, for example. will you focus on model building and algorithms, or are you going to focus more on the practical work of business decision making? So to give an example, maybe you aren't interested in building models and focusing on program, but you are interested in helping the business to improve. Let's say you work in banking, or you are interested in this industry, and then the data scientist or the analytics the analyst, the related skills that you need and that can help you augment the business decision making. So you don't even necessarily have to get into the real grit of model algorithm and model building and algorithm development if that's not your real expertise and if that's not your interest. And your portfolio will help you discovering what your real interest is and what you're good at and what not. So data science and analytical skills can be used also as supportive aids to help you grow your own customized career path in a particular domain. And this is very interesting because you can tailor your own career path. And I would advise, strongly recommend people tailor your own career path. There's so many journeys that you can go, do what fits with you, what you're good at, and what you like, and then start adding the skills and the proficiencies that you feel help you and help your business. Always try to find this match between what can I do for the business and how does it help me in my skills, in my career. And if you can find this perfect match, your career will prosper, I think, much faster. So if you work, for example, in finance, you can learn the data science skills that are necessary to help you progress in a way that works best for this finance business. And vice versa, if you're already a data scientist, you might be hired to work specifically in finance and build your career around this focus if you like that. So the bottom line is that investing in a data science career is going to make you better positioned for a new job opportunity. Whatever job you're going to do, this is going to help you big time, as every job in the future will have some analytics component in it, and you will be a more attractive candidate for a potential hire. As I said, whatever job you're going to do, whether you're going to be a CEO of a company later on, this will help you big time. And I think it's really interesting, and you should think about more about this in detail. Now, the last point I want to make about education that has to do with communication. And we started in the beginning already with the visualization, which can really help you with the communication. But I can't stress it enough how improving your abilities to communicate both verbally and in written, and communicating, let's say, with your visualizations is going to help you as a data scientist and as a data analytics professional. Your job hinges on how you're able to communicate the results of your findings, as many people will not understand it. So you need to communicate it. And keep in mind, not everyone else is a data scientist. Maybe the opposite. Hardly anybody is a data scientist, so they will not understand. Some people are business focused and others are technology focused. So to give an example, how do you communicate to business units and IT? You have to do it separately. They require a different type of communication, and their goals might align, but their objectives are going to be entirely different. So you have to be able to speak and to write clearly in a way so that different people get what you mean and understand what story the data tells, and they understand how to do their job in order to achieve the company objective. If you can support them, they will support you. So Stuart, I think I've said it multiple times, the importance of keeping up your educational level and how important this is, and how great this foundation is for whatever career path you're going to take. But I think you have a poll left as well, which I'm
Yeah,
curious what the answers will be.
yeah. So this asks our audience what they're most interested in learning, what their plans are. We'll just leave this open for half a minute. 4, 3, 2, 1. And data science, AI, machine learning are the top answers for what you'd like to learn. About a third of you would like to start that right away, which is excellent. We can help you with that. Like to move on. We haven't much time because Ronald has a hard stop in about 4 minutes, so I will only be able to ask one or two of the questions. But I did want to ask Ronald if you could answer for people who have careers in other areas like manufacturing or engineering, what is the best plan for them to transition into analytics or science, data science?
Yeah, so it really depends, of course, on your background because there's a lot of career possibilities. If you want to start your career and you have no experience in analytics at all, you can start as a data analyst or a junior data scientist, or you can stay within your job but start doing additional courses in the evening hours just to start supporting your business from an analytics perspective. Then you have, on one hand, the business value, and you can bring the value as either a data scientist or a data analyst. If you want, let's say, to deep further in it, yeah, there's all different kind of possibilities, and it really depends on your background where you can go in the direction of a BI developer or an application architect. If you like uh, programming, if you like database, you can become a database administrator. If you have an architectural background, you can become a data architect. If you, let's say, and what most people said, they want to become a data scientist, yeah, basically then start as a maybe as a data analyst or a data engineer and grow to a data scientist, or take a side route from a machine learning engineer. So it's hard to give you a black and white path where you say, okay, if you are in a different industry, like manufacturing, this is the route. It depends on your background. But I think in general, what we can say is if you are, for example, in manufacturing, but that is, I think, for every industry, start thinking from your organization perspective, what kind of goals do you want to achieve? What kind of data is available? And what skills do you have to contribute in that domain to either, yeah, automate it, make it faster, better? And this way, I think you can, yeah, define already your route. And if you trying to stick, um, let's say, stick a pole in the ground where you want to heading to, then you can define your career path. But um, as I said, it's not black and white. It's really depending on your background and the direction where you want to go. But on the other hand, I think starting is the most important because that will guide you what you like and what you don't like, and maybe start just doing a study in parallel from your daily job, because then you can find it out while you're moving ahead.
Okay. So that's, I know that you have a hard stop. I'm going to let you go, Ronald. I'm going to apologize to everyone whose questions you weren't able to get to, but um, I will go ahead and finish out the slides so you're free to drop off if you need to.
Yeah, let me give you some slides. Is this the
I've
slide?
I've got I've got them available here as well.
Okay, perfect, perfect.
So
Thank you all, and yeah, good luck with your career.
all right, and thank you so much to Ronald. Um, Ronald's
Yeah,
LinkedIn address is Ronald dash Van dash Loon dash 5411A, and I'll put that link into the chat for you so that you're able to directly contact him. Um, and I'd like to mention we have a couple of programs that, aside from our postgraduate programs in data science and in data analytics, which I've mentioned in the chat and Q&A, We have Intro to Robotic Process Automation, one of the sets of tools that's valuable in doing things like pre-processing data, as well as AI and machine learning, which is another area that's extremely important, peripheral to data sciences. As Ronald mentioned, you can't have a Google search engine without deep AI and machine learning behind it. So I will put into the chat all of this information and allow me to do that. So in your chat window now, you're getting links to the different courses as well as Ronald's LinkedIn. You have, I've seen one or two questions about future webinars, and we do this as a continuing series. So we will have webinars nearly every week, depending on the topics. Ronald usually comes back once a quarter with us, and we have other data science speakers, as well as speakers on career strategy, other particular technical areas like cybersecurity. So please keep in touch with us regarding our webinar program. Our next webinar is a career masterclass with Vanicola, the managing director of Kalari Capital. She's going to talk about how ambition can't be locked down, how even in the lockdowns, people are pushing their career goals ahead, how top professionals thrive through the pandemic, how she's helped entrepreneurs start companies during the pandemic, and I'm going to put the link to register for that into the chat. Hold on for just a moment. And there it is. And with that, we conclude our webinar today. Please follow us on our social media channels at Simplilearn on Facebook and Twitter. You can look up Simplilearn on LinkedIn, connect with us there, follow us there. And we look forward not only to seeing you at future webinars, but to having you join us in the Simplilearn learning community. Thank you all for being here today, and good luck in your careers.